Hello friends, welcome to our YouTube channel. In today's topic, we are going to discuss about the VI characteristics of the diode. Now first of all, we'll see that what is VI characteristics. VI characteristics means the graph between the applied voltage across the diode and the current flowing through the diode. The graph plotted between the applied voltage and the current flowing through the diode is called as a VI characteristics of diode. Now this VI characteristic, it is divided into two parts. The first part, it is forward characteristic, and second part, it is reverse characteristics. Okay. Now first we'll concentrate only on the forward characteristics. Let's start. Now you are watching here that right hand corner, it is shown there the symbol of the diode. PN junction diode has symbol. That symbol is shown by there. It is just like a triangle and a straight line at the top of that triangle. Okay. So base of the triangle will always represent the P type, and the top of the triangle, that straight line, is represent as a N type. So hereafter we'll discuss, whenever we discuss the circuit diagram, that diode symbol we'll use. Okay. So that is the symbol. Now see here in the graph. Here the graph forward characteristic is shown. Now in this graph you are observing that on x-axis there is forward voltage. So voltage given to the forward biasing. Okay. And on the y-axis we are taking here the forward current. Forward current means what? In forward biasing, the current flowing through the diode, that is forward current. So this graph is between the forward voltage and forward current. Okay. Now you observing here that as we increase slowly the forward voltage, the initially current is 0, and after some time it slowly gradually increases from some particular voltage, that is point A. So after point A, the current is observing here that increasing exponentially. This is forward graph. This graph is called as a forward characteristics. Okay. And the point A, it is important point. That point A is called as a knee voltage. Knee voltage, let's define it. Knee voltage is the voltage at which the depletion layer width of the diode becomes 0. Now we know that in forward biasing, when we increase the voltage, forward voltage, the depletion layer width starts to decrease. So when it exactly becomes 0, that point is the knee voltage, and hereafter the current will start to flow through the diode. Now in this diagram, A is the knee voltage. Okay. Now for silicon diode, knee voltage is 0.7 volt, and for germanium it is 0.3 volt. Okay. Now we have to calculate some concepts from this graph. Now observe this graph, we are just extending it. Observe this graph. First we'll discuss about the static DC resistance. Static DC resistance means what? It is the resistance offered by the diode when applied voltage is DC. So what is the forward voltage we are applying here? If it is in the DC, then the resistance offered by the diode is called as static DC resistance. Okay. Now it is denoted by capital RF as shown in the formula. RF is equals to, what is the formula for that? RF is equals to forward DC voltage divided by forward DC current. It is simply V is equals to IR. Resistance is equals to V divided by I. Okay. But here forward voltage divided by forward current. So RF is equals to forward DC voltage divided by forward DC current. Now from the diagram we can calculate that also. The forward DC voltage, it is OX, and forward DC current, it is OQ. So we are writing finally RF is equals to OX divided by OQ. So this is the method to find the static DC resistance. Okay. Now the second concept will derive from this graph. It is dynamic forward resistance. Dynamic forward resistance means what? It is the resistance offered by the diode when the applied voltage is in AC. So when we apply the AC voltage, then diode offered the resistance. That resistance is called as a dynamic forward resistance. That resistance is denoted by small rf. And how we can show by formula? See here, rf is equals to, now what is rf? It is 1 divided by slope of the graph. 1 divided by slope. So first you have to calculate the slope and then invert it. 1 divided by slope. Or otherwise we directly can write here 1 divided by slope is equals to Oy minus Ox. See the diagram. Oy minus Ox divided by OP minus OQ. Okay. So when we calculate this, we'll get here the dynamic forward resistance. So these two resistances are important concepts of this forward characteristics. First is static DC resistance and second is the dynamic dynamic static resistance. Okay, hope you understand this. Okay, now we'll move towards the second concept. Now we start with the second part, that is reverse characteristics of the diode. Okay, now you are observing here the graph. This graph shown here the reverse characteristics of the diode. Okay, in this graph you are observing that on y-axis we are taking the reverse current and on x-axis we are taking the reverse voltage, and there is I naught. That I naught is called as a reverse saturation current. That means initially when we increase the voltage slowly, there is a small increase in the current, that is IO, and after that that current becomes constant. So you are observing here straight line up to the VBR. Okay, that straight line, it is nothing but the reverse saturation current. That value is IO or I naught. Okay. Now after that VBR, you are observing that there is abrupt increase in the current of the diode. Abrupt increase means what? Suddenly the value of current it increases. That VBR is nothing but the breakdown voltage of the diode. As we know that in reverse biasing, if we increase more and more voltage, the diode becomes damaged. It crosses its breakdown voltage limit and it becomes damaged. So that VBR represents the breakdown voltage of the diode. Okay. So at that VBR, the current suddenly starts to flowing through the diode abruptly. Okay. So that VBR and I naught are important points in this graph. Now we'll discuss some other points from this graph. Now observe this diagram. In this diagram, we are going to calculate the static reverse resistance. Static reverse resistance, it is represented by capital R and subscript is small f. So RF is the static reverse resistance. It is the resistance offered by diode when the applied voltage it is DC. Okay. So when DC voltage is applied, then resistance offered by diode it is static reverse resistance. So what is the formula? Here it is shown there. RF is equals to applied reverse voltage divided by reverse saturation current. Okay, what is it? Applied reverse voltage divided by reverse saturation current. So from the diagram we can write here that it is nothing but the OZ, the value of voltage is from O to Z divided by I naught. Reverse saturation current is I naught. So it is the static reverse resistance. So next concept we are going to discuss from that graph. Now see here, dynamic reverse resistance. Dynamic reverse resistance, it is denoted by small rf. So both the letters are in the small letters rf. Dynamic reverse resistance. It is the resistance offered by the diode when the applied voltage is AC. Okay, when applied voltage is AC, resistance offered by diode, it is dynamic reverse resistance. Now see what is the formula for that. Here shown it is RF is equals to the change in reverse voltage divided by change in reverse current. So whatever is the change in the reverse voltage, we have to take in the numerator divided by change in the reverse current in the denominator. So that will give us the dynamic reverse resistance RF. Okay. Now see this diagram. This diagram will give you the combined both types of forward characteristics and the reverse characteristics. We are showing here the forward in the first quadrant and reverse in the third quadrant of the graph. Okay. Now knee voltage A is also shown there, breakdown voltage is there, reverse saturation current I0 is also there. So combinedly IV characteristic of any diode in both the biasing forward and reverse is shown by this diagram. Okay. Now hope you are understanding our lecture. If you have any queries, then comment in the comment section. Like our videos, share it and subscribe our channel.